What is up, all you amazing people watching this video right now? So we started looking at area of circles, and we are going to continue with area of circles on page 458 in your book. So go to page 458, and we're going to talk about the area of a circle. Area is measure of the interior surface of two-dimensional figure. As with polygons, the area of a circle is expressed in square units. So, the area of a circle we looked at and kind of derived the formula in class is that it's the product of pi and the square of its radius. R in symbols, it looks like this. So, some people think that pi are round, but pi are squared. Oh my gosh, you guys, check back for more jokes later. So here's our circle. Here is r, the radius. Remember that radius is the distance from the center to the outside. And the area of the circle is pi times the radius squared for any circle. So, there's Harley. She's not appearing, but you can hear her. Hold on a second. Okay, I had to take care of something. But we are back on page... Okay, it's very hard to record while people are still awake. That's why I do it at 5 o'clock in the dark. And some of you think that I've been kidnapped. Yes, I've been kidnapped by the people in my home. They don't let me do anything while they're awake. Anyway, page 458. So find the area of a circle if we have the radius. Again, all you guys have to do is write down the formula. A equals pi r squared. Come over here for a second. Come on. Let's go quickly. I don't want to waste time. All right, some of you have been requesting a special guest appearance. So here for the first time is Owen Donovan making his way. Okay, Harley, come here. Up. And, oh, nope, she's falling. Okay, so pi r squared. In place of r, we're going to put 14.2. So just be careful here. You want to do 14.2 squared first. Remember, order of operations is exponents before multiplication. Okay. Oh my goodness. All right. Where were we? We squared this first because exponents first, and then we're going to multiply by pi. So now, again, if we leave pi in there, just like we did with the circumference, this is the exact area, 201.64 pi. But if we want an approximate area, we can replace pi with 3.14. Or if your calculator has a pi symbol, you can always use that. So you don't have to use 3.14. If your calculator has a pi button, you can just use that. And in your calculator, plug it in just like this. And it might be slightly different from this, but almost exactly this. But maybe the decimals might not be quite this, since we're using a better approximation for pi than 3.14. But it should be pretty close to that. So see if you can do the one on page 458 at the bottom. Now, you might not always be given the radius, so sometimes you might have to figure out what the radius is first. So the city of Wellington, this is an interesting thing that just happened. They commissioned a statue to honor their former mayor. The base will be 26 feet in diameter, and we want to find the area of the base. Well, if we want to find area, we need to know radius. So our first thing we're going to have to do is find the radius, and this is on 459. If the diameter is 26, then half of that is our radius. So remember that the radius is half the diameter. And now that we have that, start with your formula. In place of r, we're going to put 13. 13 squared is 169. And then we'll still have the pi here. Again, this is the exact area. Then if we replace pi with 3.14, or if you just plug this in your calculator using your pi button, and then you'll get about 530.66-ish. So the area needed is about 530.66 square feet. Okay, so if you don't have the radius, you'll have to find it first. All right, go to page 460. And we're not going to finish this whole section today. Well, actually, I think we are. Can't remember what I put in my notes. Yeah, okay. So now on page 460, what if we don't want to find the area of the whole circle, but we want to find the area of a semicircle? Semicircle is half a circle. So think about that. If I just want half the circle, then it's just half the product of pi and the radius squared. So it would just be 1/2 pi r squared. again, semicircle is just half the circle, so that's what that would look like. So look at example 3. A wireless fence transmitter at the back door of a house allows a dog to roam freely within a semicircle that has a radius of 30 feet. So how much space does this dog have to roam? So it's only half a circle, so we only want half pi r squared. We're only going to have half the pi, not the whole pi. The whole pi is kind of a lot, you guys. Even half is kind of a lot, depending on the size. So half pi r squared. So the radius, we still are given that the radius is 30, so we'll replace r with 30. And we want to do 30 squared, which is 900, and then half of that. So you're going to multiply all the numbers together except for the pi. So 30 squared, exponents first, is 900, times 1/2 is 450. So 450 pi would be your exact area. And then again, you could plug this in your calculator or this if you don't have a pi button. And we get about 1413 square feet. So that's how much room the dog has if it's a semicircle. Now, if we have the circumference of a circle and we want to find the area of the circle, watch this video and you can see what to do if we know the circumference and we want to find the area.
To find the area of a circle when given its circumference,
first use the circumference formula to find the radius. Write the formula for the circumference. Then substitute the value of the circumference and an approximation for pi. Next, simplify the equation. Then use the division property of equality to solve for the radius r. Next, use the radius to find the area of the circle. Write the formula for the area. Then substitute an approximation for pi and the value of the radius. Now simplify the expression for the new area. First, evaluate the power. Then multiply. The area of the circle is about 28.26 square meters.
Okay, so one step I would change to that is that in the last section we looked at finding the radius given the circumference. So let's just use the way we learned in the last section to find the radius and then find the circumference. So on page 462 is the last example for this section. We know the circumference of the circle. So the circumference of the circle is 32 inches, or excuse me, 32 pi inches. So in the last section, we looked at using the rearranged version. I'm trying to think really quick. Circumference equals 2 pi r, so this is c over 2 pi. Okay, yeah. So we looked at using the rearranged version to find the radius. Instead of using the way they just showed you, we can find the radius using this formula, this version of the circumference formula, where r is the one by itself. So in this case, we are given that the circumference is 32 pi, and we're dividing by 2 pi. I don't know why this doesn't want to write for me ever correctly. So the pi's will actually cancel each other out, because pi over pi is just 1, and 32 over 2 gives us 16. So we found the circumference, or excuse me, the radius from the circumference, just like you guys just did in section 9.1. So this part is not new. Finding the radius from the circumference we did in the first section. Now that you have the radius of 16, again, you can do it this way too, but this is just might be a little bit more complicated. So now that we have the radius, we can plug it into the area formula. So now pi r squared, plug in 16 for pi, and 16 squared times 3.14 is about 803.84 square inches. So try the check problems. I want all 4 check problems complete. So I want to see work and answers for all 4 check problems. And I also want a parent signature on the bottom of page 462, please. Thank you. And that way I know that you've watched this and you are ready to work on this in class tomorrow. Thank you very much and have a good rest of your day.